Okay, this is lesson 6.2, part B, and in this lesson we're going to look at some applications of solving quadratic equations. So let's give it a shot. Example 2 says a rectangle has the dimensions x plus 8 and x minus 2. Determine the x that gives an area of 24 centimeters squared. The dimensions of a rectangle are length and width, so we can assign the first one length and the second one width, or vice versa. And this is our area. And if we remember, the equation for area of a rectangle is just length times width. So provided what we're given, length is x plus 8, and width is x minus 2. And it says our area is 24. So we need to solve what values of x satisfy this equation. So what x's could we put into these brackets that would give us 24? And in order to finish this question, our strategy is going to be to expand, collect like terms, and then isolate for x either by completing the square or by factoring. But when we complete the square or factor, if we jump back to the end of our last lesson, we'll look and it says 0 equals on both sides when you're factoring to solve or completing the square to solve. So for us to do this question, we need to make our equation say 0 equals. And the easy way to do that would just be bring the 24 over, but then we have this really weird expression on the right-hand side. So what we're going to do is we're actually going to expand and collect all of our terms on the one side. So we're going to expand this by foiling. X times x is x squared, x times negative 2 is negative 2x, 8 times x is 8x, and 8 times negative 2 is negative 16. And now we can bring the 24 to the other side and collect our like terms. Minus 2x and 8x would make 6x plus, and negative 16 minus 24, because we're bringing the 24 over, would give us negative 40. And now we have a nice quadratic that we can solve. And again, we can solve by completing the square of factoring. Generally, the accepted method is to factor to solve. So that's what we're actually going to do from this point forward. For almost all of these examples, we're just going to factor to solve. But keep in mind that we can use completing the square to solve, but we're going to factor. So in order to factor, we need to look for numbers that multiply to negative 40 and add to 6. And you can pause the video and think about this if you'd like. The numbers that multiply to negative 40 and add to 6 are 10 and negative 4. So congratulations if you came up with 10 and negative 4. We can use these numbers to write our factored form. And since this is just an x squared term, we can factor this like a simple trinomial. We don't have to use decomposition. So we can go right to our brackets, x plus 10 and x minus 4. And now to solve this, we just take each bracket and set it equal to 0. X plus 10 equals 0, and x minus 4 equals 0. Because if either of these brackets is 0, 0 times the other bracket will give us 0, so it'll satisfy the equation. And if we finish here, we get x equals negative 10 and x equals 4. Now if you notice something about these numbers, 4 and negative 10, well, if we take negative 10 and we put it into the length equation, we get negative 10 plus 8 is negative 2. We can't have a length of negative 2. If we put the negative 10 over here, we get negative 12. We can't have a length of negative 12. Negative likes don't make any sense. But if we put 4 in, we get 4 plus 8 is 12, and 4 minus 2 is 2. 4 and 2 are appropriate lengths. So that means that the only real answer is x equals 4. So this answer is called invalid. And the reason it's invalid is because it leads to lengths and widths that aren't realistic. So what we do is, to make a conclusion, we say, therefore, the value of x that gives an area of 24 centimeters squared, is x equals 4. Now negative 10 does work, but it leads to improper side lengths. So we decide that it is an invalid solution. It's a mathematical answer, but it's not an actual answer that we can use in this application. How do you know the difference? Well, you know the difference when you're given an application question, like a rectangle and area. This answer is not valid because it leads to things that can't exist. Now, if this question just said solve, and this wasn't about a rectangle, then both these answers would be fine. So we only ignore the negative answer when it's an application question and the negative doesn't make any sense in terms of the application. All right, let's try 3. Write a quadratic equation in the form ax squared plus bx plus c with zeros of negative 5 and 6. And it has to pass through the point 0, negative 30. All right, so it gives us zeros. So what we can do is we can write an equation that has zeros in it, which is factored form. And that's x minus r, x minus s, and this a is in front because we can have a different stretch or compression. It can be flipped upside down and all that good stuff. And where that factors in is with this extra point here. So your zeros are your r and your s. And your extra point is just an x and a y that we can use to find a. So here's how this question would work. We'd plug in our r and our s. X subtract negative 5 would be like plus 5. And x subtract 6 would just be x minus 6. And now we can use our point of 0, negative 30 for our x and our y. We used our r and our s in our first step. And then we'll be able to find our a. So we got negative 30 for y. We don't know a. And we got 0 plus 5 and 0 minus 6. And now we just have to do a little bit of math. Negative 30, we don't know a, but 0 plus 5 is 5, and 0 minus 6 is negative 6. 5 times negative 6 is negative 30. So now we have negative 30 times a equals negative 30. I'll bring this up over here so we can see it. Negative 30 equals a times negative 30. I'm just going to rewrite that as negative 30a. And now to solve for a, we divide away the negative 30. And negative 30 divided by negative 30 is 1. So now we know a is 1. So we can go back to this equation. A is 1, so we don't even need to write it. X plus 5, x minus 6. And then we're almost there. We want it in standard form. So in order for us to change from factored form, which we have, to standard form, we need to remember how to switch between forms. Well, right now we have factored form, and if we want to go to standard form, we need to expand. So our last step is to expand. Oh, x minus 6, not x minus 60. X times x is x squared, x times negative 6 is negative 6x, 5 times x is 5x, and 5 times negative 6 is negative 30. Now we just have to collect like terms. X squared minus x minus 30. And there is our final answer. Okay, that's it for lesson 6.2 part B. If we're going to try some practice questions for solving, make sure we try ones like example 2, where you have to come up with an equation using some information and then set it equal to something and then solve for x. Those would be some good examples to give a shot before you move on to 6.3. All right, that's it. I'll see you next time.